So after we have identified the main type of questions that we have, let's start exploring some of the answers or the statistics that could answer each of these questions. The first one is that what question that we're trying to solve. Maybe we could look at the correlation of the features and the data that we have. Let's see also some summary or try to describe our data set. Let's start by typing df.describe. Let's see how our data looks like. It shouldn't take that much of time, but let's wait. Here you go. So we have the basic statistics of how our data looks like. So the count, the mean, the standard deviation, min, and maximum. As you could see, also it has identified each of the values on each of the features. So this is our target variable, or we call it as the independent variable. Some of these features have categorical values. As you could see that on the 6, you don't have numbers, so it has returned zeros. However, for the age, you have the mean of 55 or 54 years old, and the maximum of that patient is 77 years old, as counted, which returns the rows. Let's now find the correlation. We'll find the correlation by typing. Let's run that. Okay, as you could see that it has generated the correlation. However, it seems maybe difficult to read. So let's visualize it. But first, let's add some comments so you can reference these codes later in case if you want to use them. Basic. Next, we have the correlation. Target variable. So let's do some visualization to see how this looks like in a more readable way. To start with, if you recall that we have imported our main libraries like the Seaborn and Matplotlib, so we're going to type them again here as SNS. Next, we have to import the Matplotlib. Let's accept that by the matplotlib dot. Okay. So if we assume that our data frame with numerical columns, let's calculate as we have done first on the correlation matrix, but we need to save that on um, a variable. We call it correlation matrix, so we can call it later when we want to plot our results. Co Next, let's set the figure size. Let me comment this out. store it and correlation matrix variable. Next, let's set the figure size. We'll start by calling plt dot figure fig size is equal to, let's make it 12 and 8. So that is the width and height. The size has to be now. Let's create a simple heat map. SNS from Seaborn dot heat map, and we will call our variable that we have created here, which is the correlation matrix. That is equal to true. CMAP is equal to call warm. Let's also mt is equal to 0.2f. Finally, let's add a simple title to our plot by calling plt dot correlation matrix. Finally, the last function that we have to call is just to show the plot that we have created just now. I just could see the error here. Okay, it's here. It should be true. And this should work. So let's run this. Okay, amazing. So we have this correlation matrix. So as you could see that we could see that there are some variables that are highly correlated. As you could see that CP, which I believe is the chest pain, don't worry about these because we're going to create a data dictionary to explain each of these in detail so you can understand the correlation with each of these variables to the target variable, which is whether a patient um, have a heart disease or not. So we have the CP, and what else we have? Okay, we have also the Dalach. Um, I'm not sure what is this, but we're gonna work on this, and we will find the exact meaning of this variable. I think it's the maximum heart rate. Okay, and the slope. So as you could see that we have plotted a very beautiful correlation matrix plot just to make us understand the key features or key variables that how it's influencing the target variables we have here. So in the next session, We'll create a data dictionary just to go through each of these variables with its meaning. So stay tuned.